Thank you so much, Marcus, and good afternoon, ladies and gentlemen. It is absolutely great to be part of CGU's Benchmark Awards. As a futurist, I spend a lot of my time going into research labs to see the things that they're working on and talking to scientists and innovators all around the world about the implications of the things in their labs. Without a doubt, there are an amazing number of technologies coming online right now that are going to create a world 10 years from now that will be almost unrecognizable. And in 20 years, our everyday living is going to seem like something out of a science fiction movie. It's going to be that profound of a change. There will be impacts on so many different industries. For instance, retail is going to change, transport and logistics, manufacturing, agriculture, and the list goes on and on. Along with these technologies changing industries, they're also going to create new opportunities to better manage risk. They're going to create new risk vectors, and they're going to create brand new, very expensive asset categories. So those are the things I'd like to talk to you about today. Let's start by talking about the automotive industry. As I look at technology and the verticals that will be impacted, without a doubt, my mind goes right to the auto and transport industry straight away, because there are going to be such profound impacts in the short term, in the medium term, and in the long term too. One of the things that's starting to happen from a risk management perspective and safety perspective in the 2016 and 2017 model of cars is integration directly into a car dashboard with a passenger or a driver's mobile operating system. We have Android Play, we have Apple CarPlay as well. Right now, a lot of accidents are caused when people are trying to look at their mobile phone, maybe to navigate or to look at a text or make a phone call. When all of this is directly integrated right into the dashboard, that's going to start to be a paradigm changer. And it gets even more interesting when you start to consider voice interfaces. Right now, we're still in the baby steps of voice interfaces. You've got Siri on Apple, which sometimes recognizes your voice and other times doesn't. It doesn't like my accent at all because I'm half Australian, half American, and it gets thoroughly confused. But as we start to get more and more sophisticated voice interfaces that are run by artificial intelligent agents, we're going to be able to do things like get into our car and tell it where we want it to take us instead of programming it in. If we have an alert come up, we might say to our car, "What's that?" Or it might just proactively read it out to us. This is going to fundamentally impact driver safety. There's also a really interesting technology called augmented reality, which has lots of different forms, but essentially what it does is it gives you a digital overlay on top of the real world. So it's not obstructing things that are happening in the real world, it's giving you additional information. So if we think about fleets of cars that are coming out now, they'll be integrated with the mobile operating system, and maybe they'll have heads-up displays on the dashboard. But what happens with older cars? Well, there are technology companies, including one in Israel, that has designed this system called Rego. That's a clip-on, and it has a Bluetooth interface to an app on your mobile phone, and it's giving a series of functions to you that you can control with that little yellow knob that goes on your steering wheel. So it will recognize your voice, again, fairly rudimentary, and read you out messages and let you select things by scrolling, once again, so that you don't have to look down at your phone as you're driving. There's also a really cool innovation in the world of augmented reality that came out of Samsung's Buenos Aires office. It's called a safety truck. In Argentina, one person dies on a road accident every single hour. And a lot of those accidents happen because you've got a lot of two-lane highways, and inevitably somebody tries to get around a big truck or some other slow-moving vehicle, and they have no idea what's coming out in front of it. So what these engineers came up with is a system that uses 4 really big flat panel displays mounted on the back of these big trucks and cameras on the front of the truck that's filming in real time the scenery that the truck driver sees and displaying it on the rear panel so that people who are driving behind the truck are able to see what's going on. They can tell whether there's a slow car in front of the truck, what kind of traffic is in front of them, and whether it's safe to pass or not pass. Now, if you think about that, that is a really cool innovation that's using technology that's here today. Now, this is still a prototype, but again, if you think about the automobile industry and the AV industry, how many displays are created that get turfed in the bin because they've got a series of dead pixels that aren't good enough to use in your living room? Or how many older TVs get turfed because they're not this year's model? What if we took all of that waste and mounted them on trucks and reused things that aren't really good for consumers, but put it on the back of displays on trucks to let people see what's in front of them? I'm also told that this is the same technology that the military is investigating to create invisible vehicles. And they're not really invisible, but what they're doing is creating surround LEDs that completely disguise a vehicle. So if you can imagine that you've got cameras facing in every direction, somebody looking at an area isn't going to notice it, maybe unless they're looking very hard or have sensors that can detect there's a vehicle there. And I was just at the Integrate trade show last week, and the big sexy in LED displays this year are curved LEDs. So you take that ability to curve a display and you put it around a car or a truck, well, you can imagine what's possible. Then there are other technologies that are available in the here and now for driver safety and fleet management. This is something from a company called FleetSeek, and they're a telematics company, they're Australian, and what they've designed is a camera system that's mounted in vehicles that's integrated with engine sensors, and it gives real-time telemetry back to home office. So from a fleet management perspective, you're able to see what all of your vehicles are doing, and you've got real-time video footage. Now, of course, that's also very useful in the case of an accident. You can see exactly what's happening. But moreover, you can use these same feeds for driver safety training and instruction. Now, we've probably all heard about driverless cars, and a lot of people think, well, that's kind of futuristic. They're not really rolling out right now. Well, let me tell you, the 2016 luxury models are getting very, very close. So we've already got cars like Tesla that have autopilot mode. These pictures are from the latest Volvo catalog, and it's a mainstream car. It's filled with sensors. It's got sensors in there that are able to detect pedestrians, vehicles, and even large animals. And if the human driver doesn't take action like applying the brakes, then the Volvo will slowly apply the brakes so that you don't have a collision with something that you don't want. It also has a pilot assist function where if you've got your cruise control on, it will make sure that you keep a certain distance from the cars in front of you. And once again, if you're getting too close, it will start to apply the brakes. And I don't know about you, but when I use cruise control, that's one of the things that's really annoying, is that you get people that are slower than you want to go, and you're constantly turning it on and off. It also has technology like lane assist, so it will look at the street lanes, and if you're starting to veer into the wrong lane, it will correct your steering. These are things that are happening now, and by the way, it's integrated with Apple's mobile OS. And then we have fully self-driving cars, and I'm sure everyone in this room has heard about Google cars. This is an example of a Google car that has no steering wheel, no brakes. It's basically designed for complete autonomous function. These things are not just experimental. Google's experimenting, and so are a lot of other companies. In the UK, one of the local councils is doing a trial with taxis, automated taxis in highly urban areas to pick people up and deposit them in various parts of the city. Just last week, Ford made an announcement that it is building a fleet of fully autonomous cars with no steering wheel, no brakes, no human driver. These fleets of vehicles will be commercial in the year 2021, and their target markets are ride-sharing services like Uber and Lyft. Now that's mainstream, and it's coming soon. So you might ask, with all of these automated cars, will we still have people that buy cars for themselves? And that's actually a good question for the insurance industry. You know, if you start to think about automated ride-sharing services, one of the biggest costs today with taxis is the human that's driving it. When you take the human out of the equation and you have everything automated, the costs go way down. There will be people who elect not to have cars, but for those that do, they may have little pod-like cars like the Google car, or they may end up with luxury cars like this concept car from Nissan. This is a really cool concept car that was shown at one of the Japanese motor shows a few months ago. And when you want to put it into fully autopilot mode, you press the steering wheel completely retracts, and you get this ultra-cool dashboard, but it has a lot of sensors too. And when it detects a pedestrian, it flashes a message across the dashboard that tells the pedestrian, I see you, I'm slowing down, and it goes across on the windows. And it decides that it can mimic your driving style. So there are people that, as soon as they see the green light, they like to step on the gas, they like to take curves in a certain way. Well, this car, using AI, will mimic your driving style too. So we'll see a range of pretty cool driverless cars as well. Now, with driverless cars, one of the big issues is, how do we know where everything else is in our environment relative to where this fast-moving vehicle is? Today, these driverless cars are using sensors, but where we're going to be going in the future, especially with mobile operating system integration in the car, is vehicle-to-vehicle communications. And there's already a lot of work being done on this. So cars will be communicating with each other and telling the cars around it, I'm moving at 44 kilometers an hour, and I'm going to be stopping at this address, and that's 200 meters away. The infrastructure in our cities will be loaded with sensors too. No longer will the robot driving the car have to figure out that a traffic light is about to change, because that traffic light will be transmitting to this vehicle-to-vehicle network. So will the speed limit signs. Everything will be talking to each other, and there's an opportunity waiting to happen for companies that are going to do this systems integration, come up with this traffic control system, and deploy all of this infrastructure. So what might it look like if we have fully autonomous vehicles? I'd like to show you a short clip from a company called Black Sheep Productions. It's a tongue-in-cheek look at what this brave new world might look like. Now, you might think that's really tongue-in-cheek, but just 2 weeks ago, I was reading about some research being done at MIT for what they call slot-based traffic management. And seriously, you know, the brainiacs at MIT are working on a system that would allow cars to not have to stop at traffic lights and basically negotiate with each other when something's coming. I looked at a little animated video of this, and there was only one thing missing. They forgot about people crossing the street and stepping in the way. They haven't allotted for slots for people crossing. But sure enough, we may have that as part of our driverless future. I have a feeling that traffic lights are going to be around, at least in the medium term. I don't see them going away, but they will be automated. However, in this whole area of driverless cars, there will be a lot of unintended consequences, and that's what I'd like to talk to you about next. So first of all, when you have a driverless car, one of the things you have to determine is who's actually responsible. Late last year in Mountain View, California, a cop pulled over a Google car because this car, instead of going too fast, was going too slow. It had been programmed to go only 24 miles an hour, but it was a 35-mile zone, so it was backing up traffic. So the cop comes along, wants to give a ticket to the driver, but there's no driver. The driver's seat is empty. There's a passenger, but the passenger wasn't in control of that. In the end, the cop decided to let the car off with a warning. But it raises a really good question. You know, if you've got a driverless car and there's a traffic infringement, who's responsible? It gets even more serious, though, if there's an accident. A few months ago in Santa Clara, a Google car decided that a bus was going to yield, and it pulled out and it pranged into the bus. Luckily, nobody was hurt. But again, we have issues of liability. There was nobody in the driver's seat. It was an automated car. Maybe you've got a situation where there's not even a human in the car. It's just the car. Who is responsible? What happened if someone was injured or died? Today, you'd probably say, well, that's manslaughter. Whoever was driving behind the vehicle, they'd be breathalyzed, blood tested, everything else. What happens when it's not a human in there? Is it the car manufacturer that's responsible, the owner of the car, the programmer? These are some pretty serious issues. And there are other issues, too. What happens when there's an unavoidable accident? How does the car make a decision of potentially injuring or killing the occupants of a car or running over a pedestrian? And what happens if different programs are running in different cars or even in different software versions of the same model car? Who is going to make these ethical decisions? And there is no good answer to that right now. It's something that we as a society really need to think about. There's also security. And I hate to tell you, but even today's cars have security that is absolutely pitiful. Up in Queensland, Professor Andre and his team have done studies on all kinds of vehicles. And there is something under the steering wheel of a car called a CAN bus. That's basically the brains of your car, and you can get into it wirelessly. And from the CAN bus, you can control all kinds of micro elements in the car. You can control steering, airbags, brakes, and so on. It's not hard to hack into it. What's going to happen when we have fully autonomous cars and somebody hacks into it? We need to seriously think about security issues and have it designed in as an important safety feature in this world of automated vehicles, and frankly, even in the world of vehicles today. And then there are other ripple effects on the economy. I've already talked about liability, but what's going to happen with all of the states and municipalities around the world that raise revenue from traffic infringements? When we have a fully autonomous world, that revenue stream is going to go completely away. When the speed limit is being broadcast by signs owned by the municipality and the car follows it, there's no money to be made. Where it's going to get challenging in the short term is when you have cars that are sometimes on autopilot mode and sometimes being driven by a human. And if there's an accident or a traffic infringement, how do you determine who's the party at fault? And that's going to impact all of you in the insurance industry. I think what will happen is that we'll start to see vehicles fitted with the equivalent of airplane black boxes that are able to tell you who was actually in control or what was in control at any given point in time. But there are other ripple effects in society. As we start to see more and more automated vehicles, what is going to happen to all the people who drive for a living? there will be some people who really in 10 years will not be able to continue their driving career. And in some areas, it's going to happen faster than others. One of the places that it is ripe to happen is in long-distance driving and trucking. So if you imagine you have these long, lonely strips of road where there's no pedestrians crossing, that's a relatively easy thing to orchestrate for an automated vehicle. But there's another ripple effect. You know, all along these roads, we have hotels, we have truck stops, we have bed and breakfast. All sorts of things in the economy rely on truckers and tourists driving through their area. When these things are completely automated, what happens? A few months ago, I was doing a workshop for a group of CEOs, and I was talking about driverless cars. One of the guys in the audience is the owner of a radio station, actually a series of radio stations, and he said, you know, this is going to have a profound impact on my business because most of our advertising is in drive time morning radio, and if people aren't driving their cars anymore, what is that going to do to my business? So if they don't have to have their hands on the wheel, they may not listen to talkback radio. They may be looking at email or doing something else altogether. There are a lot of industries that are going to be impacted. For instance, parking garages. If people don't own the same number of cars that they have now, what's going to happen to parking garages or smash repair places? You know, so there's a whole ripple that we need to think about. So now I'd like to turn to the commercial property segment because there's some really interesting things happening there as well. How many of you have heard of the Internet of Things? Everybody, how many can give me a good definition of it? Don't tell me the definition, just raise your hand if you think you could. Now, it's one of these buzzwords that nobody actually knows what it means. Let me give you a really simple one. When I talk about the Internet of Things, I'm talking about any kind of gadget, piece of clothing, hardware, car, anything that's connected to the Internet. So if it's got communications and it's connected to the Internet, that's part of the Internet of Things. Where it gets interesting, though, is when you have these things attached to sensors that are able to measure things in the environment. So it may be a sensor that's in an office building that is able to figure out when people are in the building and only turn on heating or air conditioning when there are people there. It may be a sensor that's sitting in a big trash container and it's measuring the level of refuse and sending out signals when it's actually full enough to bother collecting trash. Then there are controllers, and these are things that are able to take real-world action. So being able to turn the heat on and off, that's a controller. So there's all sorts of things that will comprise this Internet of Things. So one of the early areas, aside from our communications gadgets, where we'll see connectivity to the Internet is in wearables. Is anybody wearing a wearable now, like a smartwatch or a Fitbit or something? A couple of you. When I talk to companies, a lot of the CEOs are interested in ways that they can use information from wearables to help assess the health and safety and well-being of their workforce. And one of the questions they inevitably ask is, well, how can we get people to use wearables and let us have access to that data? One example that I've seen is out of America with BP, where health insurance in the US is very, very expensive. And they also know that unhealthy workers cost them more in terms of sick days and productivity and everything else. So they've designed a wellness program where if people enroll, they get a Fitbit, and in recognition for sharing data, they reduce the cost of health insurance. Now, wearables are going to get much more sophisticated in the future, too. Already at the University of California in Berkeley, they've designed a prototype wearable that is able to do a molecular analysis based on your sweat. It can detect things like fatigue and all sorts of medical conditions as well as drug use. So this information is getting very, very personalized. And these kinds of sensors, because that's what it is that's doing the measurement, it's a sensor, they're going to be woven into our clothing as well. Already in Australia, Rio Tinto in Newcastle is using a smart cap. basically a baseball cap looking thing that has sensors across the band that is able to detect when one of their drivers is going into a micro fatigue state, and it's able to send an alert so that the person stays awake. As you can imagine integrating this into your clothing, and you combine it with haptics, which is the sense of feel, imagine that your clothes sense that you're about to fall asleep and you're driving, and instead of sending an alert to your mobile phone, it shakes you awake. This is the kind of technology that's being worked on today. And then we come back to augmented reality. I mean, this is actually one of the game-changing technologies, AR, VR, holograms. This is an example from a company called Dacry in California. They've designed a smart helmet. So it performs the same functions as a helmet does today in a construction site, with big added bonuses, is that superimposed on your field of vision is information, say, about what's in this series of pipes that you're looking at, what kind of temperature they are, what kind of pressure it's under, because it's integrated with the back office. Using infrared vision, you can see as a worker whether something is hot or cold and touch it or not touch it, as the case may be. And because you've got these loads of cameras, you're also able to have remote collaboration real time with colleagues in the back office. There are lots of applications for this technology. Then we get to another really cool technology, which is facial recognition. It's a form of biometrics. So I'd imagine most of you in this room are familiar with customs and SmartGate. And that's what you call a cooperative system, where you've posed for a picture and then you stand there and wait for it to just identify that you're the same person in the picture. What researchers are already developing are systems that are able to do facial recognition of people in a crowd at an angle. This fellow down here is Brian Lovell, and he's one of the leading researchers in Australia in this area. He's got a company called Imagis Technologies, which has designed a system to do just this. So it can pick out people in a crowd, but moreover, these systems are increasingly being integrated with artificial intelligence, where they're also being able to pick out the emotions of people that they're looking at. I was talking to a group of CEOs last week, and he's in the property leasing area. And we were looking at emerging technologies as part of a workshop and how it might be useful in the property sector. And he said, you know, the combination of facial recognition along with smart door locks could be really useful in my business, because one of our biggest cost factors is when we have tradespeople who need to do work. We've either got to have our staff that goes out with a key and meets this person, or they have to pick up a key and then go back, and of course we're charged for time. What if we had a system that we could say this person using their face is allowed into this building between these particular hours, and the door opens when the camera at the property recognizes the person who's authorized? You're no longer giving the key out to a tradesperson. And again, that really impacts security in terms of who might further go along and burglarize a building later on. There are other applications in the commercial property segment too. Imagine that you had a system that had pictures of all your staff and people who are meant to be on premises. And what it's doing is it's looking for people who aren't in that database, looking for the exceptions, and picking out people who might be hanging out and maybe be looking nervous, or, you know, some other telltale sign that they're up to no good, and raises alerts based on that. Sensors are going to be everywhere that we can imagine, in our traffic infrastructure, in agriculture, looking at moisture levels, on our bridges, checking for stress, in buildings checking for stress, all sorts of things. There's even a company in America that does environmental monitoring that has designed a drone that has a sensor that's able to measure air pollution contaminants out of the plumes of factory smokestacks. So as you start to think about getting real-time information, there are ways that risk can be mitigated by getting the right information to the right people at the right time. A really great example of this is right here in Sydney. Sydney Trains has invested in a whole range of sensors that they're calling Mousetrap. And the reason they call it that is these sensors are able to sniff out the smell of permanent markers or spray paint. And as soon as this is detected, it sends a real-time feed with CCTV camera images back to the train office and to the transit police so they can see what's going on, and then they can catch the perpetrator in real time when the train stops at the next stop. Vandalism costs the trains about $34 million a year. This system cost about $500,000 to install. I think you can see the ROI. We're also going to see flying robots, affectionately known as drones because of their noise, throughout our environment. When you take a drone and you equip it with a high-definition camera, as well as infrared cameras and other sensors, there are lots of interesting things that can be done. Videography is going to be big, especially in the real estate agency area. One of the interesting applications that I like in the insurance segment is using drones to assess property damage when you have a disaster. For instance, the Brisbane floods or the fires in Victoria. In fact, IAG is one of the pioneers in Australia of using drone technology for damage assessment. IAG used drones to look at fire damage last year. We're going to see drones for asset inspection. A lot of my customers are in the telecommunications and utilities industries, and they use drones to look at the condition of electrical substations, of cell towers, and all sorts of places where it might be dangerous for a human to go. There's a company in the UK that designed a safety drone which looks like a beach ball. It's called Gimbal, and it's meant to go into disaster areas, and when it hits something, instead of crashing, it bounces like a beach ball. And if it hits a person, it's got this carbon fiber steel cage around it, so the propellers don't hurt the person who might be injured in this disaster situation either. And another one that I like that is brand new on the market, is just coming out now, is an alpha drone, and it's designed for building surveillance either in the home or industrial segment. And it's fully autonomous, meaning there's no human controlling this drone. And what they use is a mobile technology called geofencing to basically draw a line around the property, so that's only where the drone flies. And there are sensors on the ground that do things like motion detection. So if a motion is detected on a property, the drone flies out and gives real-time video feeds back to the owner on their smartphone so they can see exactly what's going on. There are also initiatives around the world for self-repairing cities using robots. This is one of the coolest that I know about. It's in Leeds in the UK. And they're designing drones that will be looking to repair things automatically without any humans getting involved. One of the modes that they'll operate is with little drones that have manipulator arms that are able to do things like change street lights. They'll also have drones that go along and assess road conditions, and if a pothole is forming, they'll assess where the pothole is and send another little robot out to patch it. They have this vision of never having a street closed for repairs. They're also looking to design these little robots that will go into utility pipes and report back conditions inside the pipes. These same kinds of technologies can be used in industrial properties to assess and repair damage that is happening there as well. Our factories of the future, and even today, are becoming increasingly automated. There is a possibility in the very near term that we will have factories that are completely robot-driven, and when they detect that a part needs to be fixed in the robot, they'll send a signal to a 3G printer. The 3G printer will print out whatever part needs to be installed, and another robot will come and install it. It's this whole idea of self-healing factories as well. We're going to see lots of robots in our future. They are a huge new asset class. And they're interesting because there's so many different uses. They're not all going to look like little humans from science fiction, but we'll see them too. In Japan, there's a robot called Pepper that telecom giant SoftBank launched last year as a combination of robot, plus cloud-based service that downloads new apps, plus maintenance. They've offered 1,000 units at a time every month for the last year, and every single month they have sold out in exactly 1 minute. And it's not just people buying them. Businesses are buying them and then using them in retail shopfront. Up in Brisbane, Domino's Innovation Lab has designed this absolutely adorable little delivery bot to deliver pizzas. And it's being trialed in the streets of Brisbane right now, perhaps for eventual rollout. There's a hotel in Japan where you walk in and there's no human at the front desk. You're greeted by a T-Rex. There's a Hilton Hotel in McLean, Virginia, where if you go up to the concierge desk, you've got a cute, tiny humanoid robot called Connie that can give you information about the hotel and surrounding areas. There are a couple of bricklaying masonry robots, one in Australia called Hadrian, that can work 24/7 building things. There are submarine robots that are able to do undersea inspection, let's say before you're about to lay a cable or do something else under the water. The types and variety of robots is just mind-boggling. But along with that, there's risks. Robots are used in telesurgery. So imagine an operating theater where you've got a robot that's got a laser and a scalpel and somebody's hacked into it and you're the patient on the table. That's not a good situation to be in. And frankly, one of the things that happens with so many emerging technologies is that security is an afterthought and privacy is an afterthought. And that's where I want to leave you today, is to think about the implications of security and privacy in all of these emerging technologies. And I think that there's a real leadership role that the insurance industry can play here. Right now, in so many tech areas, this is just missing in action, security and privacy. But what if insurance ratings also included assessment of the security of a particular product, and people pay more if it's an insecure product? That would have a ripple effect on manufacturers who design these products, because people aren't going to want to buy a robot that's more expensive to insure than another robot that has better security. So as you're looking at this brave new world, I'd like you to think both about the opportunities and the risks. And thank you so much for allowing me to talk to you today.